Okay. So today's lesson is still related to equations, all right? But now we're going to talk about different types of solutions that we could have given any equation, all right? Up until this point, all right, I know this looks like a lot, but I'm going to explain some of these notes already as we progress through. Up until this point, we've been solving equations using some different methods, all right? And we've always gotten x equals a number, right? Just any, x equals 2, x equals -2. Could be any number that we've seen so far, correct? We haven't seen anything crazy, right? There's other solutions that we could have if we go through our process of solving, all right? So having x equals a number is just us finding one solution, right? However, if we were to solve an equation, which is our first step, so we're always going to go through solving an equation, then we're going to determine the type of solution that we have. If we have x equals a number, like we said, that's just one solution. However, there may be times where maybe our variables eliminate each other. So I'm left with maybe one number equaling the same number. So say I, solve an equation and I get like 5 equals 5 on both sides. Well, is 5 equals 5 always true? Yeah, right. If you have 5 of one thing, it's the same thing as having 5 of another thing, right? When that's the case, we say we have what's called infinitely many solutions. So if I solve an equation and instead of having like x equals a number, which is one solution, and I have one number equaling the same number, that's what's called infinitely many solutions. So this is a new term for us. I would suggest writing it down so we're aware of what we need to understand when we have that situation arise, okay? On the flip side, if I have a number equaling a different number, so say I have like 3 equals -2. Well, is having 3 equals -2, is that the same thing on either side? Does that make sense? Is having 3 of something the same as having -2 of another?
Sorry,
That's
so
okay.
we're looking for a kid.
Okay, no worries. So having $3, is that the same as owing $2? No, right? It's not the same value. Don't overthink this, okay? When that's the case, we say we have what's called no solution. So when you don't have the same thing on either side, you have no solution if your variables get eliminated. Is that clear with everybody so far? Are there any questions about that idea? Okay. So what I want us to do now, we're going to go through 3 examples, all right? And so long as we're participating, we'll get through the examples relatively quickly. And then in the end, we're going to determine, do I have one solution? Do I have infinitely many solutions? Or do I have no solution? All right. So this first example here, I have 5 times the quantity x plus 1 minus 7 equals 3 times quantity x minus 1 plus 2x. So you see I have some distribution. I'm going to have some combining like terms on both sides, things that we've seen up until this point. All right. Let's take a second, jot that down if you need. So on the left-hand side of my equation, what should I do with this 5 here? Distribute, right? Anytime that I see parentheses, I'm going to distribute. So what does that give me on the left-hand side? What's 5 times x? What's 5 times 1? 5. And I still have the minus 7, right? On the right-hand side, what should I do with this 3 and the numbers or the terms inside the parentheses? Distribute again, right? What's 3 times x? What's 3 times -1? -3, and I still have the 2x. Okay. Everybody with me so far? On the left-hand side, let's just combine our like terms. I have 5x, 5, and -7. What can I combine over here? 5 minus 7. What's 5 minus 7? -2. Good. So I have 5x minus 2. On the right-hand side, I have 3x, -3, and 2x. What 2 terms can I combine? And what's 3x plus 2x give me? So I have 5x minus 3. Good. So over here, I combined the 5 and the -7. On the right-hand side, I combined the 3x and the 2x. Well, let's go through our normal process of solving. I'm trying to get all of my variables to one side and my constant terms, so my numbers, to the other. So what do you think I should do from this point? Move the 5x to the other side. Okay. So when I do that, I have to subtract 5x, right? Well, what's 5x minus 5x? What's going to happen over here? Going to cancel out. But over here, I also have 5x minus 5x. What's going to happen there? It's going to cancel again. And I'm left with -2 equals -3. No solution. Nice job, Isaiah. So you're able to connect those two ideas from what we talked about before versus what we're doing now when we're solving. Having -2 of something, so like owing $2, that's not the same as owing $3, right? They're different numbers on either side. Well, let's go back to the chart that I made here in the beginning. If I have one number and it equals a different number, so in here, in this case, -2 equals -3, I have what's called no solution, all right? So if you see this, if you go through this process, and it's going to be a lengthier equation, so make sure you're taking your time. -2 equals -3, and when that's the case, you would say you have no solution. Okay. Are there any questions about that first example? Okay. We're going to take a look at two more examples. One of them is going to be a little bit longer, just like that last one, and the other one's going to be a little bit shorter. This next example has the equation 4 times x plus 1 minus x equals 3 times x minus 1 plus 7. All right, so take a second, jot that down if you need. So 4 times x plus 1 minus x equals 3 times x minus 1 plus 7. All right. What should I do on the left-hand side to start? Very similar to what I did in the last example. What's that? Distribute, right? So I'm distributing what? What number? 4. Good. So just worrying about the left-hand side for now. But you're right. So when I distribute the 4, what's 4 times x? What's 4 times 1? And I still have that minus x on the outside, right? On the right-hand side, Isaiah, you pretty much already said it. What do I have to do with that 3? Distribute again, right? What's 3 times x? What's 3 times -1? -3, and I have the plus 7. All right. Is everybody with me so far? All right, Chase. So then what do I have to do on the left-hand side? Since you're with me. Well, you can talk to me now. What's 4x minus x? Is what? Because you were with me, right? Well, then why would you say that? It's totally disrespectful. We understood? What's 4x minus x? 3x. right? And those are the only two terms that I can combine on that side. On the right-hand side, what can I combine? What two terms are common between these three? So I have 3x, -3, and +7. What can I combine there? What's -3 plus 7? Not -4, +4. What's that? Exactly. So you do the subtraction and then you keep the sign of the higher one. Will somebody read out what I have right now? Equals. Do I have the same thing on both sides? So then what kind of solution do I have? So if I look at my solution types, the same things on both sides, right? If I were to simplify this and we're trying to get variables to one side, constant terms to the other, notice what happens on both sides. All of these things are going to cancel. I'm left with 0 equals 0. Well, is that the same number on both sides? Right, just like I had the same expression on both sides. Does that make sense? When that's the case, if you have the same thing on both sides, you have what's called infinitely many solutions, right? So the only two different scenarios that we have on top of what we've already learned, right, is question? What's that? I literally, I can't hear you.
Yeah.
Yeah.
See the x by itself, that minus.
Oh, the minus x, this right here. So this is minus 1x. So if you want to put the 1 in front, that's fine. Is that what you were asking? So it's 4x minus 1x, which gives me the 3x. So that's how I got the 3x plus 4. On the right-hand side, the only things I can combine are the -3 and 7. So I have -3 plus 7, which gives me that 4, and this 3x is by itself. All right.
Yeah, very good question, because I noticed that students even later, 10th, 11th grade, still aren't sure what that means. So if you don't see anything at all in front of the variable, it's automatically 1. So that's a good question.
Really good point. Either way, though, so now I end up with 3x plus 4 equals 3x plus 4. Again, if I move some things over, I have 0 equals 0. The only two, like I said, the only two new solutions we have, if I have the same thing on both sides, that's infinitely many. If I don't have the same thing on both sides, so two different numbers equal to each other, that's no solution. The last solution type I have is something that we've already seen before, right? So I had 2x plus 7 is equal to 11, right? If I have an equation that looks like that, what do I have to do on both sides to get my variable by itself? Subtract 7. So I have 2x equals 4, right? And then how do I get x entirely by itself? Divided by 2. So I get x is equal to 2. Well, then what kind of solution type is this if I end up with just one number? One solution, right? Makes sense. If I have x equals a number, that's just my one solution type. Okay. Whereas if I have the same thing on either side, this is infinitely many solutions. And if I have something different on either side, that's no solution. So these are just different solution types that we're going to be able to see and work with given any problem that we encounter from here on out. Okay. Are there any questions about any of those examples? Anything that we covered today in class? In the back, there's another outlet. Okay. So that's it for the mini lesson.